it is water cooled. When water comes from the jacket, water then enters into the cylinder head, and then it cools the exhaust valve, and then it goes out from the engine. So this is the brief of your exhaust valve seat, and it is detachable, so you can remove, you can do the machining, and replacement can be done. Now, the hydraulically, we avoid the uh, tappet. We don't use the tappet clearance, so it is hydraulically actuated. And but thermal expansion, how it has been taken. You see one thing, the thermal expansion, whether you are using hydraulically operated valve or a rocker, thermal expansion will be there because it is depend on the engine operating condition. During the operation of the engine, the temperature. Okay, so now can you hear me? There was some network problem. So let us start again. So in this case, can you see the screen? Hello, can you hear me? So can you hear me, all of you? Okay.
Yes, Chief, now I can hear you.
Yeah, okay. So let us start. So hydraulically actuated, now there will be expansion of the valve spindle, whether it is hydraulically actuated or it is uh, rocker arm operated. So uh, that expansion has to be taken care. In rocker arm, what you do, you are actually using the tappet clearance. But whereas the hydraulically actuated valve, there is no tappet clearance because it is on top of the valve, it is filled with hydraulic oil. So how it has been taken care, this expansion, once there is an expansion in the valve spindle, so the volume on top of the valve spindle, that is there is on the top of the valve spindle, there is a hydraulic piston which will move up. So the volume on top of the piston will reduce, the pressure will increase, so that much volume has to be released and removed from the system, and it is done by the relief valve. So that is the way it is been. Yeah. So if there is any loss of oil, that is compensated because the inlet, there is a non-return valve where the oil is supplied is at the pump, and it has been, that loss is compensated from there. And so the hydraulic pipe, there is a requirement, should be setted so that if there is any leakage, it should not splash onto the hot surfaces, and there will be chances of fire. And that is the reason it is shaded, so that it gets accumulated within the hydraulic high pressure pipe and the shaded the protection, and then it gets drained out. There is a drain provided. Yeah, it is closed by the air spring. So there is a air piston underneath. The air is filled, the cylinder is filled with air, so it gives you upward force so that it closes. So it is hydraulically open, and by the air spring it is closed. So now before we go into the next slide, let us, and the air is supplied from the control air system. It's at 7 bar, and there has to be a non-return valve in the supply line so that when a valve is open, pressure is increased, it should not escape from the air cylinder. So let us see this diagram, exhaust valve diagram, then we'll come to the slide. So this diagram, if you see, this is the pump. So you can see the my cursor, isn't it? So this is the pump, and this pump, it is operated by the cam. So this pump has got a piston. This blue color, what you see is the piston, and this is the oil supply, and there is a non-return valve which is not shown here, through which. Okay, can you see the screen? Exhaust valve. One of you unmute and tell me. Hello, can you see the screen?
Chief, you are no, not now.
Okay. Okay, now you can see, isn't it?
It's trying. It's trying. Yes. Okay.
Yeah. So if you see this screen, so there are, this is the pump which is operated by the cam. So it is a reciprocating pump. Normal reciprocating pump, it's when it is moving up, this volume is reducing and equal volume has to be displaced here. Once it is displaced here, this piston has to move down. This is the operating piston which is on top of the your exhaust valve spindle, and that is the way it operates. And now there is a non-return valve, as I told you here. So if there is any loss of oil, so that it can be compensated through this oil supply. And here, if you see, there is a dumping pin. What is the purpose of this dumping pin? When the valve is opening, we want to open the valve quick so that the large amount of exhaust gas can come out from the cylinder. But so when it is closing, yeah, when it is closing, that time we don't want to ask.
እየተቆራረጠ ነው ገባ ወጣ ይላል ዳስ
See, there is some internet problem.
ኦንላይን እንማር ብለን ስለወሰን ቁርፎ ነው እንዴ? ኧረ በጣም ከባድ ነው።
Hello. Yeah, let us continue. There is some disturbance. Today morning was very good.
ኧረ ከባድ ነው ነገር
What happened?
I think it needs strong.
Yeah, tell me.
connection.
Yes.
Hello?
Yeah. Can you hear me? Tell me. Hello. Yeah.
What are the
Yeah. Tell me. You want to say something?
Yes, Chief. The connection is very poor. So it's
Yeah, that's
in
true.
and out.
Yeah, that is true. Evening now. Let us try now. You just mute all the microphone. So in this case, why the dumping is provided? Because we don't want to close faster. If it is closes faster, then it will hammer the seat, the wall seat and the wall face and the seat face will be getting damaged. That's the reason we don't want. So here what happens when it is opening, that time this dumping pin is stationary. The piston, which is the blue color, which is moving down. So the clearance between the dumping pin and the piston will increase. Once it increases, that space will be filled up by this oil. Once it is filled up by this oil, now during the closing, what will happen? There will be a slow rate of movement upward direction. This, because this oil has to come out from this space for closing it. So this is the reason it dumping the movement of the upward movement of the spindle. And there is a vent on top. If any air is trapped inside the hydraulic system, it has to be removed because otherwise there will be knocking, because the air is incompressible, so it will get compressed and it will close very fast, so which you don't want. And this air piston, which is moving upward direction, because underneath this air piston, and there is a this violet color, what you see is the air cylinder. So the air piston is attached to your, by the cotter attached to your spindle. So when this spindle is moving down, air piston also moves down. And underneath of the air piston, that is the air cylinder, it is filled with a 7 bar pressure. That is the control system, compressed air system it's applied to, and there is a non-return valve. Once it is filled up, it should not leak out from this. And if there is a leak, it will be compensated, but it should be sealed unit actually. Once it is supplying, because this pressure is very high pressure when it is closing, that time it will escape from here, which we don't want. Because in that case, what will happen? The pressure, when it is moving down, the pressure is increasing because your volume is reducing. So there will be a particular pressure when it is moved completely, valve is open. And that is around, from 7 bar, it will become around 30 bar, for an example, and 32 bar. So in that case, what will happen? That pressure, once this hydraulic pressure is released, because this piston, when it is moving down, this hydraulic pressure is released, but there has to be a upward force. That 32 bar gives a upward force, which is closing the valve. So if suppose the non-return valve is leaking, then what will happen? Some mass of air will come out. So this pressure will drop. That pressure will not be sufficient. So we need to close the valve completely. So that's why there should not be any leakage of this non-return valve. Now another thing, this this piston, there will be some leakages. It cannot be 100% sealed. It is purposely, it helps actually, this leakage. Once there is a leakage, this lube oil, where it will go? It will go, come and accumulate on the top of the air piston. Once it gets accumulated on the top of the air piston, then when it is moving downward, that cylinder surface will be lubricated and some of the oil will come below the air piston. Is it clear? And I think one of your microphone is on that you put off. So Petrus, tell if you can communicate Gizao, share the password and ID to join. So,
Okay.
yeah. Is it clear till now what I said? So this oil will get accumulated on the top of the air piston, and then there will be some leakage. When the piston is moving down, what will happen? Some oil will leak through and it will come at the bottom side of the air piston, which actually helps us because this air, because of the change of pressure, this oil will mix with your air, and then it will adheres on the surface of the spindle. So when the spindle is moving up and down, that time it gets this the guide and the spindle, you need lubrication because guide and spindle there is a relative motion. So it's done by this oil top part. The oil will on the surface of the spindle. When it is moving down, that oil will enter into the bush and the spindle, in clearance between the bush and the spindle, and it gets lubricated. Now what will happen? There will be continuously, there is some leakage of oil which will get accumulated at the bottom. Once it gets accumulated at the bottom, what will happen to the volume underneath of that is the air cylinder volume? It will reduce because bottom is liquid. So this volume will reduce, but the mass of air is same. So what will happen? The pressure will increase. So once the pressure is increased at a particular pressure, suppose we want 32 bar to have it inside once it is compressed to close it, close the valve. So at 32 bar, there is a relief valve is put here on that oil drain line. So that relief valve will lift at 32 bar. So what will happen? This oil which has got accumulated at the bottom of the air cylinder will come out through that because relief valve will lift and allow that oil to, and then again at 32 bar it will close. It means it will maintain a 32 bar inside the pressure when it is compressed. And this another air is supplied to the valve, which is the sealing air, and also it does the air is does also lubrication, but air is not a good lubricating property it is having. So another purpose is the sealing, so that we don't want any exhaust to enter into the bush and the spindle. So this air we are continuously losing. It comes here and it moves down and it goes to the exhaust. But it is very little amount and it is designed that way. So this is give a sealing so that no exhaust can move upward direction. So the exhaust will go to the atmosphere. Otherwise, if the exhaust enters into the spindle and the bush, what will happen? This will get seized because there will be carbon deposits and the valve will get stuck, which we don't want. And then this valve rotor is provided. Why? How does it work? First, let us see. This works means the valve is open. It works as a nozzle. This side is the cylinder side, which is very high pressure, and this side is the atmospheric pressure because this is connected to the atmosphere. So the moment it opens, what will happen? The pressure energy will convert into the kinetic energy. And with that kinetic energy, high velocity exhaust will hit the vanes, and then it will turn certain angle, and then it will go to the atmosphere. What is the purpose of it? Purpose of it so that the valve rotates, so the temperature in the combustion chamber, the temperature is not same in all the, it is not uniform. So once it rotates, suppose it does not rotate. Suppose this portion is high temperature and this side, this portion is low temperature. So what will happen? This portion will expand in different way than the other portion. So this valve will deform, which we don't want. Because if the valve deform uniformly, it does not expand, then what will happen? The sealing will be affected. It will not seal properly. And once it starts leaking, it will get damaged. It will get weakened because of the high temperature, because during the combustion, with the flame will come out through this and the valve will become weak, and finally valve will get uh, burnt out and valve will get damaged. So once it's keep on turning means next injection, this portion will not be here. Some other portion will be here because it has turned slightly. So the uniformly it will be heated. So it will not get damaged. And another advantage why we have this, when it is closing, when it is turning, that time if any particle or the deposits on the valve seat or the valve uh, contact area between the seat and the valve, and it will get grinded off. It will not allow it to make deposits. It will remove the deposits. These are the advantage. Now, now any questions on this diagram? Tell me. Yeah, I have to tell me.
Chief,
Yeah,
can you hear me?
yeah, I can hear you. Tell me.
I do have a question. How much is the pressure between the two pistons, between the operating piston and the air piston? Is it an atmospheric pressure or something else? And the second question is there any drain from the space? I mean, if the oil is leaking from the vent, from the hydraulic, and it's accumulating, there should be drain, yes?
Yeah.
That's my question. Thank you.
There is a drain. Another diagram I'll show you. There is a drain from top. When it is closed, that time what happened? This piston is slightly projected above the cylinder, so that it can come out from the side. And that drain is connected to this drain. This drain is not shown here, but there is another diagram. I'll show it to you. There is a drain. So that once it is in closed position, the piston, the top of the piston, whatever oil is getting accumulated, that gets drained out from the side. And first question, tell me again the first question. Have to.
The first question
Yeah.
was the pressure between the two pistons. I'm expecting that it's atmospheric pressure, or it's something else.
You are talking about this hydraulic piston?
Yes, between the two pistons, between the operating piston and the air piston, there is a gap. I mean, there is a free space.
So, no.
Yes, that one.
This one?
Between the air spring, no, down.
Yeah, this
between
one?
the operating piston,
Yeah.
above that.
Above that. This is the,
Yes,
there is
that one, that
no
one.
pressure
Yes,
here.
yes.
There is no pressure. There is a drain. So drain is
That's
open to
atmospheric
the,
pressure, yes?
yeah, atmospheric. It is a normal pressure.
Yeah, that's my question.
This,
Thank you.
yeah, this side is not pressurized. Yeah. So any other questions? So let us go to the slide, the description of it. So this air which is supplied, which is, carries a little lubrication oil, so that because it gives the lubrication between the your exhaust valve and the guide, because there is a relative motion there. And also it cools, because lube oil, it cools air also, that supplied air, not only it does the sealing as well as it does the cooling, because continuously there is a flow. So inlet to the air temperature is less. So this is the purpose of this sealing air. And excess oil, as I told you, it gets collected and then it gets drained to the collecting tank. Now, this has also been covered. That's airlock. So top of the piston. That's why the vent is provided. So nowadays, all engines are automatic auto venting. You don't have to do it manually, which used to be where earlier, means long back. But now it is auto venting system, because the hydraulic system, we don't want any air in the system. Then it will not work. And there should be a non-return valve, so that the high pressure should not get released. And hydraulic, this is the relief valve which has been provided, that is top of the piston, so that it has the dumping effect. So, so there is no hammering onto this, because it releases as the pressure increases, it can release the pressure. So dumping arrangement, what you have, relief valve you have, it is fitted on the, it is not shown, but it is fitted on the pump, not the actuator. Dumping is actuator, which I have just explained. And wing, this is also explained. It is the same thing as written. Kinetic energy hits the vane and then it turns, so that it even temperature you have and the build-up deposits will not be there in the valve seats. And cage, it is made of cast iron, and guide also, so that because that is not subjected to this adverse condition, high temperature, high pressure, high pollution, so it can be made of cast iron. And molybdenum steel we use for the valve spindle. And valve spindle, the valve seat is molybdenum steel, and the valve spindle we use the valve, that is the molybdenum chrome alloy, which is actually high temperature resistance, as well as the high corrosion resistance, as well as high erosion resistance. It can withstand the high mechanical stress also. And you can have a stellite welded on the surface, the meeting surface between the valve and the seat. This also improves the property, that is the high corrosion resistance, high wear resistance. It increases, so that because when the exhaust is passing, it's like with high velocities passes between the valve seat and the valve, because it so acts as a nozzle. So there can be erosion because it carries many particles. So the heat resistance mnemonic alloy, that is 60A, which we do use, which is a very good for that environment. It work very good, and it is all the engines they are using, engine maker are using this alloy for the valve head. Now valve head we make it by this mnemonic alloy, but the spindle, which is not subjected to that that adverse condition, like valve head is subjected to that adverse condition. So what we do, the valve head, it is made of mnemonic alloy, and the uh, spindle is made of the steel. So the friction, there is friction welding. How it is made? Friction welding. This is the way it is made. So this is your valve, and this is valve is hold in the lathe, and this valve head, for an example, it ends here, and then you have the spindle, which is made of steel, which is here, and then this we with the lathe, this is turned, the head is turned, but the spindle is not turned. Spindle is hold in a vise here. But at the same time, when it is rotating, there is a hydraulically there is a push from this side direction. So this, what will happen since it is rotating, this surface, there will be high temperature generated because of the friction. Because this is stationary, this is rotating. And at the same time, you are pushing it. So what will happen? At high temperature, there will be a diffusion, this area, and it will get welded. It is called friction welding. It is a special tools has been used. And then once it is welded here, then it will become one piece. And this, before doing so, this is aligned properly and then it is done. It is like with that, it is automatically gets welded because of the friction and very high temperature it produces. Any welding, what you do, what we use, whether it is arc welding or the gas welding, we increase the temperature so that it gets diffused together to metal. Here also it is same. Only thing, this temperature we increase by the friction. And uh, is it clear that's how it is? So this is the way it is manufactured. And then the valve is been overall, during the overall, uh, be careful because the valve and the valve seat, they are of different angle. The reason for it, this different angle is because if you see this portion, so this portion if we look at, so this will be like this. So mass around this area is less than mass around this area. So the expansion definitely will be more at same temperature. Uh, Yo, are you online? Uh, one of you, I think, Hilo Michael, wants to join. Tell him to join with the password and ID. Uh, so, okay. So, is it clear? This mass of this area is less than this area. So, definitely the expansion in this area will be higher than this area, though they are subject to the same temperature. So, what actually done? Suppose this is the seat. There will be valve angle will be different. So the valve angle for the seat, for an example, these two are not the parallel. If it is parallel, for an example, you can lap it. But the thermal expansion is different in the valve in different area. So that angle is kept so that what will happen to this area, suppose this is the area which is the combustion area. So in that case, this portion will expand higher than this portion. So at operating temperature, it will become parallel. So in operating temperature, valve and valve seat will become same phase so that it will do the same. So if, be careful, morning also some of you had asked that he had seen, some of you have seen that there is a lapping. So be careful, follow the, uh, somebody's microphone is on, just put it off. And if you want to have a question, then you put it on. So this angle is kept. That is the reason never lap it. You see the manual whether they are allowing it to lap or not. If manual says yes, you can lap it, it means this angle is same. And if you have a when you grind it, this is your valve, you are grinding like this in the grinding tool. You fix it in the grinding tool, and there is a grinder which is grinding your seat, the valve. And we have the seat which is grinded here. So this is the seat. So these two, seat angle and the valve angle, is not same. Most of the cases it is not same. So don't do the lapping. If you do the lapping, what will happen? Suppose you do the lapping, you get the contact face same, but in operating condition, this will change. In this condition, when you are doing the grinding, that time it is, when you are doing the grinding, that time it is the cold condition. But when it is in operating condition, that time sealing should be there. So because of the differential expansion, this angle is different, kept different. So is it clear? Okay. So that is the reason it is shown that it is written that you should not do the lapping, because otherwise you will not get the correct angle. Now the rotation and the air spring. So we have the rotation because there are deposit from where it comes, especially this vanadium. Vanadium is highly corrosive and it makes the deposit as high temperature. So melting point, this melting point is high, but when it mixes with 1:3 ratio with sodium vanadium, the melting point reduces. So it gets melted. Once it gets melted, it will make a deposit, which you don't want to make deposit on the surface of the valve and the valve, and the valve seat. That's the reason the rotation of the valve is so important for this purpose also. And this is very, very highly corrosive. Once the deposit is made, and very hard deposits, you cannot remove that deposit. Only, it will damage the valve seats, and it will not close also properly the valve. And once it is leaking during the combustion, all the height, the flames will move through that, and then it will become weak valve, and then valve will get damaged. And another thing, this impingement, the flame impingement, because of the your combustion, because of the combustion, if it is poor combustion, the impingement also will be there on the valve. And valve, if does not rotate, this impingement will be at the same pace, and it will become weak and it will get damaged. That's why, especially from the poor combustion, the impingement will be there. And if the fuel injector is defective, your penetration will be high, it will impinge on the valve and it will get damaged. And if it is rotating, it will not be impinged at the same point. It will keep on changing the position. So this is the purpose of your valve rotation. So the temperature gradient will be equal and the deformation will not be there. It will be equally expand, so the sealing will be proper. And the air spring, as it is already explained, so it closes as it gets compressed and then it closes. And then it causes also the check rod is provided. What is check rod? Actually, we need to know that the valve is opening and closing and turning at the same time, turning also or not. So how do you see that check? This is the check rod. This is one of the simplified diagram. You can use it for your exam purpose preparation. So this check rod, this is the air cylinder. Now, half two had a question. If you see this diagram, this air piston is slightly projected out from the cylinder, isn't it? So oil gets accumulated when the piston is downward motion. That time it will get accumulated. But when it is valve is closed, this oil will flow at the side, and this is the overflow, and then it comes to the drain and it goes out. There is a drain connection in this side. Both this complete the drain will be this oil will get drained out, and this is the relief valve which is actually connected to this bottom side of the cylinder, air cylinder. So once the it gets accumulated oil, pressure is increasing at an one pressure, its set pressure, it switches, it opens, and this oil will go out to the drain. Is it clear? The drain. And now this lifting of this the check rod. Check rod, how does it work? When it is moving, motion is reciprocating motion, that is vertically it is spindle is moving up and down. Check rod you can disengage and engage. So if it is engaged, that time you can check, yes, it is moving up and down. This check rod also move up and down because it is on top of the air piston. And the air piston will move together with the spindle. Now, how will you come to know it is rotating or not? If you see carefully here, there is a slot here. And this check rod is resting on this slot. Suppose the check rod is resting on this, because this spindle is rotating. Your air piston also will rotate because it is attached to the spindle. So what will happen? At one point, the check rod will come onto this. Once it comes onto this, then you can see there is a slight upward movement, and this will come, it is rotating again, there will be a slight downward movement. That is independent of this opening and closing movement of the valve. Let us see how, if you see the top view of this. So suppose we have this is the air piston. If you see from top, now there will be a slot. So this slot is not all around. It will be around this. Now in that diagram, the check rod is in the slot. Now once this is rotating, then what will happen? This check rod will come out from this slot and it will rest on this surface that is slightly above this slot. So by seeing that, you can make out it is the turning on not. What we can do, whether exactly it is to know whether it is turning or not. So this is the suppose this is the your check rod, and there is a tube. In this tube, the check rod is moving up and down, and this tube has got a slot. So we can mark at the lowest position. When the check rod is at the lowest position, we can mark with the marker on this tube. So now once this it has come out from this slot, what will happen? This check rod, the position, it will be slightly higher. So by doing this marking, you can make out, it means it is turning. This is independent of the movement of the opening and closing. Opening and closing movement will be much higher. So suppose this is the opening, but the moment it will come out from the slot, if it is turning, then this will not come up to this. This will come up to this. Is it clear? Understood? This one? How you can make out that it is rotating or not while in operation. This exercise you need to do during the operation of the engine. Now there is a oil bleed valve. This oil bleed valve, if you see, it is at the top of the cylinder. So the any air it is getting accumulated at the top, it should move out from this. So what we do, we bleed some oil, slight, very little quantity, whether there is air or not. So what is the, yeah, tell me, Fatene, tell me.
Okay, it's very good. What about if we see the working condition? This check rod is up and down, but sometimes if they stop or start at remain position, if that working the exhaust valve or maybe slightly out the guide this check rod.
This check rod is the for the operation to check the operation of the valve, and it checks only two things. One is the opening closing, another is valve rotation for the BMW. And this you can disengage. That you lift it and turn it 45 degree and it will get disengaged, and you can lock it on the this tube on top of the tube. So this tool is the purpose for this check rod. This check rod name itself, it's checking something. What is checked? It checks the valve is opening and closing as well as valve is rotating. Is it clear, Fatane?
Yes, clear, clear. Chef.
Okay. So now this is the one bleeding. Oil bleed means we allow some oil to bleed out continuously so that it ensures. The problem is if there is air trap entrapped into the hydraulic system, it will close so fast and there will be a knocking and it will get damage your valve and valve seal, which we don't want. So we allow some oil to remove from the system. What we do, it will not affect the operation of the valve because for opening the valve, you need certain pressure. So what we do, we make up this pressure. It means after releasing this oil, what will be the pressure that is sufficient to operate them? And then there will be a less volume that will be compensated through this supply, which is at the pump. So this pump. So this is the makeup with non-return valve. So it will get compensated from here. So it will not affect the operation, normal operation of the valve. And for the Sulzer engine, how does it work? There is a, how do you check actually? Sulzer engine, there is a side class on the exhaust valve, and that side class you can see that the piston is moving up and down, as well as there is a marking on the piston. So if it is turning or not, that you can see. Because like the valve rotor for the four-stroke engine, how do you check? You put a paint mark, isn't it? So you know that that point is rotating on you. Here also at the side of the air piston, there is a marking. So by which you can check whether you can confirm that the valve is rotating or not. So this is the way. So then, but the modern that intelligent engine, they don't have this. They have the sensor. By sensor, they can check that it is opening and closing. Even they check how much it is open. What is the valve lift and rotation also they can check by the sensor. And this, the lubrication already I had explained to you in the air spring cylinder. This is the explanation. It is the same explanation. And the bottom part of the your exhaust valve spindle. Top part, it is lubricated. That I told that to the spindle surface, it is adhered with oil and it's entered into the top part of the bush, and then it is lubricated. The bottom part, what happened? the cylinder lubrication which is injected, that does not get burnt out completely. That the portion which is not burnt out, which moves away with the comes out from the cylinder with the exhaust, and that oil gets stick onto the surface of the valve spindle, and when it is moving upward, that goes inside. So any relative motion, whether it is downward or the upward, it gets lubricated. Lower part is lubricated like this. But the exhaust will not enter. Only the lube oil which is adheres on the surface of the spindle, that will enter. That is the we have already studied the lubrication in bearing. That is one of the lubrication is your boundary lubrication. That is the first layer, which is because of the surface asperity, it will be on the spindle. It will adhere to, and that will give the lubrication of between the valve spindle and the valve guide. So this is the bottom part of the spindle and the bush lubrication. Is it any questions on exhaust valve? And there are certain explanation. If you see this, there are two cells at the bottom here, which is this is the air cylinder, and bottom is the bush. So these two cells, if it fails, how do you come to know? So there is a telltale hole in between two cells. So purpose is from outside, we need to know whether this seal has failed or not. Otherwise, what will happen? This air will come, will leak through, which we don't want. So from here we can see, and if it is damaged, we dismantle and overhaul it and renew the cell. Is it clear everything, or any questions on the exhaust valve? Because next is relief valve. Any questions?
Chief,
Yeah,
this is Haptu.
yeah.
Maybe I didn't follow if you said before, but can you please explain about valve drop?
Valve drop. What did you mean, a valve drop?
In the assignment, there was a question about the valve drop.
That is okay. This assignment you are talking about. That
Yes.
valve drop means, it means there can be uh, damage to the valve. That is related to the damage to the valve. That is
Yes, I mean, I was like thinking that if there is, I mean, if from direct meaning of the words, it's like a valve drop. I mean, the damage is because of the dropping of the valve, or I mean, from
drop.
this diagram.
Yeah, dropping of the valve. Valve can get
Yes, I
damaged
mean, if
and
there
it
is,
can drop,
yeah,
and that is that assignment is related to the damage.
yes, and how
And
it can happen. I mean, how the valve can be
yeah,
dropped or something. I don't know. I'm not clear with that. That's why I'm asking.
yeah, the valve can spindle can get damaged and it can drop. It can part and drop, and then what will be the uh, consequences? So what we'll do, that particular question, okay, next class, because this chapter will continue. Next class, I'll explain to you. Okay, because I'll have to open that assignment. I'll explain in the next class. Because the
Okay,
assignment you have already submitted, so there is no problem of discussion giving you the answer. Okay. So any other question? If not, then let us go to the next, that is the relief valve. Why do you have the relief valve? It releases the excess pressure from the cylinder. If we don't need release the excess pressure, then what will happen? The component has got a capacity, design strength, which cannot exceed. So the component will be damaged. It can be cylinder liner, it can be piston crown, it can be cylinder head, exhaust valve which is exposed to part of the cylinder head can be damaged. So this to avoid this damage, the pressure should be released. That's the reason we have the relief valve. And this is normal relief valve spring loaded, and this is made of stainless steel because it is exposed to the high corrosive, high temperature, high pressure. So it has to withstand those. So it is stainless steel, and it is a meter seat. Means it is uh, inclined. It is when it is seats and the valve seat and the valve. It is so this is at angle, so it calls meter seat. So this is the valve. Suppose this is the our this is valve and this is the valve seat. So when it is at angle, it called a meter seat. Nothing else. It calls meter seat. Okay. So and we use the helical spring, and it is spring loaded. So let us see the diagram first, then we will come to the description. So this is the valve. You can see it is at angle, that's why it is called meter. And this is the valve flap, and this is the spindle by which it is keeping enclosed because of the spring force which is downward. And this is the passage which is connected to the cylinder head, which is subjected to the cylinder pressure. Once it is increased, it is usually the maximum design operating pressure plus 20%. So 1.2 times setting will keep. So if it reaches to that, it will open, and there are the passages through which these holes it gets released. So it is this is the way it works, and there is a spring retainer, and this is the spindle moving out, and this space there are passages. So if there is once it is lifted, there can be some leakage, and it goes to this chamber, and this chamber we don't know. This has to be depressurized. Suppose this space is pressurized, then what will happen? This spring will force is pushing it down as well as the gas pressure. So the opening pressure will change, which you don't want. That's why be careful. These passages should be clear always. Otherwise, this set pressure will increase and it might damage the cylinder component. And how much this valve will lift, that also there is a restriction. As you see, this is the stop ring, and there is a gap between the stop ring and the valve flap. So it will lift this much only. It will not lift more than that. So this is the lift also, it's controlled. And if there is any excess pressure, it will get released, and again the pressure will drop, and with the spring force, it will close. This is the simple spring-loaded relief valve we have for the cylinder head. Now, tell me, how many of you uh, have not seen relief valve in the cylinder head, main engine cylinder head? Have anybody of you have seen that there is no relief valve? Or all of you have seen? So there are design. There you might not have relief valve, but then how the pressure is released in that case. So what happened? The cylinder head is secured by your studs. Then those studs are elastic. So what happened? The complete cylinder moves up. Once that complete cylinder slightly moves up, it is the excess pressure comes out from the between the cylinder liner and the cylinder head. Because the advantage is that why do they use? For an example, if there is a liquid inside top of the cylinder, the piston crown, it can happen because of the leakage of the water, the jacket water, it can be fuel accumulation. Then what will happen? Hydraulic pressure will be generated. And this valve is not meant to release that. It is not having that capacity. Whereas the exhaust means the gas pressure it can release, but those quantity of hydraulic oil has to be displaced. It cannot be displaced. So in that case, the whole cylinder will lift, and the larger area it has got space to come out that liquid. So gas also can be released as well as the liquid also can be released, but not many engine has got that. And that engine, there is a soft iron gasket between the cylinder head and the liner top. That engine, that gasket will not get damaged. But if other engine, if it is not designed for that, that gasket might get damaged if it is containing that relief valve. That is the reason how to avoid that situation. Suppose you have relief valve, that arrangement is not there. You need to avoid the situation. What you do in that case? So we do this way. So during the slow turning on the before starting, that is the reason the blow through has been done. We keep the indicator cocks open, and it expels any leakage. Because in what situation water can enter into the accumulate into the cylinder when the engine is not running. When engine is running, that time water will not get accumulated. There can be water going inside, but that water will get evaporated. And when it is pressure is higher than the expansion tank, the gas will leak to the expansion tank, not the water will enter. But whatever water will enter, maybe during the uh, suction, water can enter, but that will get evaporated because of the high temperature. So that's the reason. This is the precaution we do take so that that situation does not occur. And there are certain cases when there can be relief valve can be lifted. What are the situation it can lift? During the maneuvering. Why during the maneuvering? During the maneuvering, it is at slow speed. Maybe oil is not atomized properly because at low load, as well as there can be leakage of oil from the injector and can accumulate, and then it can have a violent fire. Once there is a violent fire, the pressure will be very high and it will lift the relief valve. After that, it will become again normal. And plus, before the maneuvering, maybe during the priming, oil has entered into the fuel oil has entered into the top of the piston crown because you are turning the engine and it was leaking. So it gets accumulated during the maneuvering. There can be an explosion and the relief valve can leak. This can happen during the slow turning also. It is the normal problem. That is the reason during the slow turning your indicator cock is open so that any accumulation it should come out. And violent also this too slow. If it is engine speed is too slow, your atomization is not proper, there will be accumulation of the fuel and that might have an explosion and relief valve can leak. Fuel injector, if it is leaking, then also it will happen. During the priming, suppose it is leaking, that time it will happen. And then fuel pump setting, if it is too high, that is pump setting too high means that is the quantity. Quantity fuel rack is not adjusted properly, it is high. Then what will happen? There will be a violent fire and that will lift the relief valve. Then incorrect timing. Timing, suppose it is advanced too early, because there is a limit to the how many degree you can advance. Because by doing the advancing, you are getting high power. But it should be within the pressure. The peak pressure will increase, but the peak pressure should be within the design limit. So if the advancing is not correctly done, it is too advanced, it is done, your peak pressure will be high, and that will cause the lift of the relay valve. Then starting air when we use for the brake. When we do use for the brake, uh, suppose when during the crash stop. What is crash stop? Crash stop is something like, suppose you have the full ahead, you want to give certain condition as arise, so the ship has to slow down immediately. Suppose for an example, when the ship crossing the canal, especially for the convoy in the canal, like for an example, the Panama Canal. So that time there is convoy. Suppose the ship in front of your vessel reduce the speed. Now your ship also immediately has to reduce because of some reason they have reduced. So you don't have time. So what you do, you full ahead to full astern, you give for an example. In that case, what will happen? The moment telegraph you put to astern, your reversing mechanism is switched over, changed over from ahead to astern direction. So your distributor, your pump, whether it is cam, whether it is roller, shifting of roller, so it will shift. But your engine still running in ahead direction. So what will happen? This air, our engine is started by the direct air injection. That's the method we do use. So in that case, your engine is still running in ahead direction. You'll get a wrong way alarm. But wrong way alarm does not allow to inject oil, but it will allow to inject air. Air injection will not stop. So now your air in this actually particular crash stop is there in another chapter in detail. That's why I'm not going into that details, but in brief you'll understand what I am saying. So what will happen? This air is injected into the cylinder in wrong angle because it is still running in air direction. So this air, instead of turning the engine, what will do? It will try to stop the engine. It will have a braking effect. So that is the reason it is called brake. So because of this braking effect, what will happen during the compression? This air will be injected because of the rotation of the engine in wrong direction, ahead direction. So if the rotation, suppose it is running on clockwise direction, piston is moving up and you are injecting the air. So what will happen? Instead of turning, it will try to reduce the RPM and it will try to stop the engine. So that's what we do by crash stop. During the crash stop, what happens? Now your pressure will increase and it can increase to the set pressure of the relay valve. And if it increases more than the relay valve setting, once it reaches, then relay valve will lift, and that time there is no fuel inside. There is air inside. That air pressure will be released through this relay valve. So that's why the relay valve can lift during the crash stop. It is a normal thing. When you use the crash stop, it might happen because of the high compression pressure. And valve lift during the running, which is indicated. If the valve is lifted, it means it is overloaded. Engine is overloaded. Overloading means it is the pressure is high, peak pressure is high. It is, and the timing in also may be fault. So you need to check the camshaft drive for the timing. And you need to investigate and rectify the problem. Is it clear what I said just now? Any questions? Okay. So the gas, now the one I was talking about, that it releases the gas pressure, excess gas pressure. It is designed for that, not for the liquid. So in the event of cooling water or the oil, that is the reason before starting blow through has to be done, so that it does not damage the cylinder component. Now another component in this chapter, that is the cylinder head. Now all the engines we do use this type of cylinder head. It is all engines, any makers we do use. We have a central board which is to accommodate the exhaust valve, and this cylinder head is cooled by board cooling. Board cooling we have seen already in the cylinder liner chapter. The board cooling is very effective and it can reach to the very close to the surface on the inside surface, so that where the exposed, where the high temperature is exposed, so that maximum heat can be removed, so that the temperature can be maintained. This also, the cylinder head also, you use the board cooling. And there are holes at the periphery. Those are the holding down bolts. So that is the elastic bolt which is this cylinder head secured onto the cylinder block. And these two bolt which is it's shown, it's for securing your exhaust valve. And there are pockets which is for cylinder, that is the fuel valve as well as the relief valve and air shutting valve, so on. So sometime the relief valve is incorporated into the, it means it is two assembly together, the indicator cock and the relief valve is it is assembled together. What is the reason? Because we make a hole on the cylinder head, it become weak. Instead of making two hole, one for cylinder, one for the indicator cock, one for the relief valve, we use the same passage. We put the both relief valve as well as the indicator cock. It means relief valve will be the first and then indicator cock, because indicator cock, relief valve should not be blocked. So it should be subjected to the cylinder pressure. So this is the cylinder head we do use. Center, we use the exhaust valve because we get the benefit of the scavenging, which is more important. We can put the center, the fuel valve, which is the best location for the fuel valve, but we do the compromise. So and for doing that compromise, we have to use for the two-stroke engine more than one injector. It may be two, it may be three. We do use two or three, depending on the size of the engine. As the size of the engine is larger, it is three. As is smaller, two. But we cannot use one, because if you use one, it will not distribute. Oil will not be distributed throughout the combustion chamber. So uniformly, it will not be distributed. That is the reason we use more than one. So this is the board cooling, what I told you, it is the same. So the thermal stress and the mechanical stress we can maintain within the design limit. And what is the material, how it is produced? It is the forged steel. Forging is done still, and the board for board cooling is made. And sometime, this exhaust valve, we use the mnemonic 80A. This is the best material is developed for the exhaust valve to work in that environment. And this, for an example, this two engine RTS 68T, 58T, this engine, they use three injector. So it means there will be fuel injector pockets, three pockets will be there. And then 48, it is less, so it uses the smaller in diameter, so it uses two fuel injector. And so that the distribution of the oil is uniform, symmetrically. And anti-corrosion cladding. What is this? Sometime you'll see the injector nozzle, which is coming out from the cylinder. That area, there is a cladding. There is a different material is used. It is purposely done. It is not that the cylinder head was repaired. It is not the repair, it is the design. So this cladding is done. Why? Because once this cladding is done, because that area is subjected to very high corrosion. So it helps us. This is the cladding material which is using. So that has got anti-corrosion property. It means the high corrosion, it can withstand. So that is the reason it is cladding. Cladding means if you see your cylinder head. So cylinder head is this one. So this internal surface, that is this is the combustion chamber. So this is the cylinder head, and this side is the combustion chamber. So this, if you see from this direction, so what we'll see two circles. So we'll see one circle and another circle we'll see. And there will be, suppose we have the nozzle penetrating, suppose 3 nozzle penetrating. So the cladding will be in this area. And it is purposely done. Is it clear? Understood? This, if you see from the bottom, on the cylinder head. So this is the different material because it is subjected to high corrosion area. So high corrosive atmosphere. So now the rocker arm. Rocker arm, why do you need the rocker arm? And this is the rocker gear because rocker arm, it's 4-stroke engine we do use. Rocker arm to open and close the valve, whether it is exhaust valve or the inlet valve. So this is the rocker arm. It is pivoted here, and this is the valve. And in this case, it is shown two valve. Two valve is advantageous. That's why most of the engine we do use two valves. And once you have the two valve, it means both the valve has to open at the same time. So you have a breech. This is called breech. And you have a push rod on this side. So the push rod uh, is operated by the cam, and accordingly it opens and closes. It depends upon the cam position. And cam is operated by the camshaft, and camshaft is operated by the crankshaft. So exact time it opens and closes. And the tappet clearance, why do you need tappet clearance? Tappet clearance is required for the thermal expansion of the valve stem. Because valve stem, when the thermal expansion takes place, it has to allow that expansion. That's the reason we use the tappet, we take the tappet clearance and maintain the tappet clearance. Now, when we use the take the tappet clearance, we need to follow the maker's manual. It provides the information. What is the, now tell me, what is the information you take from the manual regarding the tappet clearance when you take the tappet clearance? Who wants to give the answer?
Yes, Chief.
Yeah, tell me, Abraham.
So from the manual, we can see how much is the tappet clearance it must be, in which condition, in cold engine state. For intake valve, how much it must be, and for exhaust valve, the clearance is described.
Okay, yeah, that is the condition as well as how much it is. Condition means which condition you are mentioning? You mentioned
The
it,
engine,
isn't it? Hot and cold. Yeah.
yes.
Any other information which all of you have done, but that gives the information from the manual. Any other information? It also
Chief,
tells,
there's
yeah,
up to.
tell me.
This is my last shift. It was my first time that I had that experience. At the first beginning, I was confused. The topic plans for the inlet and for the outlet was the same, and I was really confused. I had experience also
Have to tell me. Have to. Yeah, can you
Yes,
hear?
Chief.
Yeah, tell me. What was the confusion on shift?
No, my experience. That's what I experienced on board was the topic clearance for the inlet valve and the outlet valve, the exhaust valve, was the same. It was 0.6, the same.
Yeah.
And I was confused at the first beginning because I never had that in another ship.
So you had always different, correct? The inlet was less
Yes,
than
I
the
had always
exhaust.
difference before, but my last ship,
Yeah.
it was the same.
Yeah, it is not necessary, it will be the different, but most of the cases it is different. Now tell me, it was same. It is as per the design only, it can be made same. But how
Yes.
it can be made same? Tell me.
The material for the inlet and for the outlet, the expansion, thermal expansion is designed accordingly.
Yes, you are absolutely correct. The material design is such so that the expansion at that temperature of inlet valve, which is subjected to the low temperature exposure, and the high temperature exposure of the exhaust valve, both expansion at their corresponding temperature is same. That is the reason you maintain same. Zero point 0.6 it was in your case. So it is the material design, because the material design will decide that how much it will expand at that temperature. Good. So now tell me, if a person by mistake uh, he taken the tappet clearance in hot condition instead of cold condition as per the manual. At hot condition he has taken, what can be the consequences? Is it clear my question? He has adjusted. Yeah, Abraham, tell.
So if it's adjusted in hot state, in hot engine state,
Yeah,
while instruction manual states in cold engine state, the it's already expanded. The valve is expanded, so the clearance will be disturbed. For example, as have to side, if it must be 0.6 with expansion, we will make more than 0.6. So during engine running, the clearance is disturbed and opening and closing timing will be incorrect.
opening and closing timing will be incorrect, but anything else it will have impact. So you have described that it will be excessive clearance, isn't it?
Yes.
Because in expansion condition it has been taken zero point 0.5 for an example, but when it is cold condition it will be more than that. Now apart from the opening and closing, it will be open late and close early, isn't it? If the expansion is clearance is more. Apart from that, any other problem?
I think, Jeff, the valve will never close. It is always crack open, so the compression will be less. I mean, the other problems will come with that.
Now tell me,
The
you
problem is clearance is too big.
yeah. If it is clearance is more, why should it remain open? Will it remain open?
Oh, sorry. It was the opposite. It will be knocking.
Yeah, the knocking will be there because the rock alarm will hit. Anything else it will happen because this is the so uh, so this is the suppose the valve stain and you have the rock alarm, so which is the push rod here and it is pivoted here. So now the clearance is met. So apart from this, it will make noisy because it will have an impact. Suddenly the load will increase. Is there any effect on the cam? Cam will have the shock loading because what will happen if you see the cam is trying to move up, but still load is not coming in because of the excessive clearance. The moment it will touch, the rocker arm will touch the valve spindle, then the load will start increasing. In normal condition, what will happen? Load will increase like this. But in this case, what will happen? There will be no load, then it will increase like this. So there will be a shock loading here. Load will not be constant. Load will increase once it is coming out from the base cell in the flank. But in this case, this time, whereas there was load here, this load, there was no load here. So there will be a shock load. Now, what it has been done, one way, if you see the slide, let me go to the slide, we use the hydraulic system. It is not the hydraulic system what we have for the two-stroke engine, the hydraulic tappet. It is self-adjusting hydraulic tappet. How it is done? It is done this way. So suppose you have the push. So this push rod, it's in, this is a push rod and this is the follower and the guide. The four-stroke engine, many of the, there are four-stroke engine that they use. And you have the follower. So here, what you have, this space, it is these two component is not directly connected. This space is filled with oil. So this oil actually pushing. Oil is incompressible. When this is moving up, this also moves on because of the oil. Now in this case, what will happen? You have the rocker arm, and if you have the clearance, whatever may be the clearance here, it will be automatically adjusted because this oil volume can be maintained as per this clearance. So this oil volume, it is not necessary it will be same. This distance changes depending on how much oil it enters. Because as long as oil will enter, as long as there is a clearance here. Suppose the clearance is, there is no clearance, oil volume will be same. Suppose the clearance increases, this oil volume, what will happen? If this clearance increases, oil volume will increase or reduce to adjust that time.
Hello, Chief.
Yeah. Have you got my
It will
question?
reduce.
If
Yes, yes, yes.
it will reduce or increase. If the tappet clearance, and there
When
is a
the
clearance here.
clearance increase, amount of oil will be reduced.
Now this
The
portion,
oil
what I have drawn, this is here, this side, and the clearance is here, tappet is here. Now suppose there is a tappet clearance. Now this clearance has to be adjusted. It means rock arm should touch here. This should be on the same line. Now here, this is the adjustment. So this distance will increase or decrease.
will increase. Sorry,
Once it
increase.
will increase,
Because
it
it's
means,
opposite side.
yeah, it will be the volume of oil supply, it will occupy more volume of oil. And then when it is moving up, there are ports. This actually, this system, it is there in one of the chapter. I'll go in details on that chapter. So this, when it is moving, this volume can be adjusted based on this clearance. Whatever may be the clearance, volume will increase. If the clearance is less, volume will reduce. Understood? That is one way it can solve this problem, the tappet problem. So if the valve, if the tappet is insufficient, then it will not close properly. That time, the valve will not close properly. There will be, what will be the consequences if the valve does not close properly? Will answer.
Yes,
Yeah,
if the valve is not correctly closed, the exhaust valve is leaking
yeah.
and it's make
Exhaust valve will leak, the power loss will be there. Anything
yes,
else? Is there any chances of damaging the valve and valve
yes,
seal?
damaging
Yes,
the
it will be valve burner.
Yeah, because during the combustion, the flame, same thing what we have seen the other cases, it is also same, and the hammering effect, because suddenly it will hit the your spindle by the rocker arm, and there will be hammering effect. So this hydraulic tappet, self-adjusting, it solves this kind of a problem. When it is a large engine, then the problem is more, because it will there will be worn out of the exhaust valve spindle top, as well as worn out of the your rocker arm contact face. So this problem comes. To overcome that, we have this hydraulic self-adjusting hydraulic system. Now tell me any question till now. Any of you, any question till now? Now, when we overall the cylinder head, the guide bush or the spindle, we check the clearance, isn't it? So how this clearance increases? What can be the reason? That bush clearance is important, isn't it? And there is a limit, we need to change the bush. But your valve is moving up and down. How come the bush is getting worn out? Who will answer?
Hello,
Yeah, tell me.
Chief.
Yeah, tell me.
It's because of carbon which entering to between the spindle and the bush. Because of carbon deposit. There will be carbon between the spindle and the bush.
Okay.
So
Any
this,
other? Any
by the
other?
spindle moving
Yeah.
upside down, the carbon will be
You
rubbing
mean
the
to?
surface.
You mean to say it is abrasive wear, correct?
Yes, Chief. Yes.
Anything else apart from abrasive wear?
Yes, Chief.
Yes, what is the reason? Abraham,
When it
tell me. Abraham, your,
One reason,
yeah, tell me.
poor quality of lubricant.
Okay, that can be, that is also, it will cause the abrasive wear, basically, isn't it? Any other reason? You are right, both of you. But apart from abrasive wear, any other reason? So,
Gas leaking, Chief. If the valve is not closing properly, there will be a gas leakage. So this will be a minimize the clearance.
so this is our rocker. This is the pivot point. This is, this side is reciprocating. I mean, this side is moving because the push rod is moving like this, and our valve is moving like this. It's a perpendicular because I'm using my finger to draw. That's why it's moving like this. So, what will happen to this point? Well, this is point A. When it is moving up and down, our valve is moving up and down. That is the vertical motion. But what about this point? Is it a vertical motion? What type of motion is it? It's not vertical motion, isn't it? So it will make a path like this. Once it is making a path of like this, and it is moving something vertically up and down, then will there be any side thrust? There will be a force, isn't it? Which is in this direction, the vertical direction, as well as the side thrust. And who takes this side thrust? This is suppose X, and this is Y. So who will take the X component? It is taken by the bush. So this is for the Rokaram design, this is one of the very important aspects. This will go in details because it is there in your syllabus. Next class will go in details. Is it clear what I said? Have you understood what I said? Because this is moving like this. This distance is same. This distance and this distance. It will take a curve on now. And because of this, there will be a side component, X component. Y component is used for opening and closing the valve. X component, when it is opening, there will be X component which will be taken by this bush, and bush gets worn out. There are other reasons that abrasive wear will be there. Because of that reason also it will be there. But the design is made such a way so this X component is minimal. We are not interested of X component, we are interested of Y component. Clear, understood? We'll go in details of that. Now tell me any other questions? Anybody? Yeah, Abraham, tell me.
But chief here for side thrust.
Yeah.
On rocker arm, normally it's designed on the edge where the force is applied.
Yeah.
It's installed with a universal joint.
Yeah. This is like this.
So it's acting perpendicular. I don't
Yes.
clearly
That is to
understand.
minimize that, but you cannot remove completely zero this X component. That's the reason design aspect to consider this X component is very important. There are various ways it is done. This is one of the way that we are telling that it is a one-point contact. So that is the reason that universal joint is provided. But apart from that also there are a design aspects so that minimum X component is minimized. The design aspect of the rocker. We'll go in details. It is there in your syllabus. Next class will go in details. Any other, this X component have you understood or not? That's why I'm mentioning that it is the design consideration. On sheet, nothing is been done because it is already designed by the maker. But maker you will design such a way so that X component to minimize. We don't want this X components, only the vertical Y component we are interested. Any other question? Now tell me how many of you did not attend daytime lecture? Uh, I am unmuting all. So how many of you have not attended?
Chief.
Petros has
Hello.
not because of his request only we are conducting the evening classes. Anybody else? Up to you have not attended, correct?
No, I was attending, but the class, the connection was bad in the morning times. That's why.
Okay. And who else?
I
Anybody else?
also
Uh,
Hi, Mikael.
yeah, you did not attend. You had any issue
I was
problem?
attending half. No, I was having connection problems. That's why, yes.
Okay. And who else? Haile
me too
Michael,
with
uh, Petros, Haftu, and who else? Abraham, have you attended in the morning?
not a complete
Okay, yeah,
lesson.
yeah,
Yeah.
because you were there in the morning. And
Yes,
what
I
about
was there, but
Fetene? Yeah, Fetene, this is optional.
Morning
Anybody
also.
can join. There is no problem. Fetene,
Morning also.
you were there in the morning?
Yeah, in the morning I was there, but the connection was bad, so
Yeah,
I don't have attend all class, so that's okay.
yeah. Okay. No, this is this anybody can join. There is no issue. I wanted to know the reason. Now, all of you have attended the electrical class. Anyway, I'll check. Now I know the reason that was I'm interested for. I'll check who all were present. That I have, I can check the record. Now, any other question? Tell me. So, if no question, then we can close it. But if any question, no problem, you can ask.
okay, no
So,
questions, Chief.
yeah. So, if no question, then let us end at this point. Okay. So, see you tomorrow morning in the
Okay,
lecture.
Chief. Good night. Thank you very
Good
much.
night.
See you.
See
Yeah.
you
Okay.
tonight.
Good night.
Bye bye.
See you tomorrow.
Good night.